All right, in this last example, it says that gravity causes a falling object to accelerate at approximately 9.8 meters per second toward the Earth. So downward, right? And if a ball is dropped from the top of a 45-meter tall building, how long will it take to hit the ground? And how fast will it be going when it hits? Okay. All right, so let's again draw the velocity versus time, right? Now, typically we take down as a negative direction, okay? So so uh, this gravitational, this acceleration of gravity is actually in the downward direction, so it's negative. So I'm actually going to draw my t-axis here because I want, this is going to be the velocity versus time again. And I'm starting at rest, right, because it's being dropped. It's not being thrown. It's being dropped from the top of the 45-meter tall building, and it accelerates toward the ground, right? With a constant velocity of a negative 9.8 meters per second. So we could write velocity is equal to minus 9.8 times the time. Okay, we have constant velocity. So I'm going to look at the area between the graph of the velocity and the horizontal axis, the t-axis. And in this case, right, because the velocity it's traveling in the negative direction, right? It's traveling downward, right? And the acceleration is negative. So we have this negative area. Now it hits the ground after it falls 45 meters, right? So once it has gone in the negative direction by 45 meters, right? So that distance is 45 meters. So then it's going to hit the ground. Boom, it stops, right? When it hits the ground. All right. So based on this, how do we figure out, we want to figure out how long it takes to hit the ground, right? How long it takes to hit the ground. Again, I'm going to call it T final. And it's this distance. It's this horizontal leg of the triangle, right? So that's my T final, right? This point here is really my T final. So it is the length of that that leg of the triangle is V final. And then this is my, T final. This is V final. This is the final velocity right here, right? That's how fast I'm going at the end of whatever that T sub F seconds. All right. And so the distance, that's this leg of the triangle, is your V final. Okay. So essentially we want the area of this triangle to be a negative 45. All right, so let's see. What do we know? We know that the velocity is equal to a negative 9.8 t, right? So what does that mean? If we plug in the t final, right, that just gives us that the v final is equal to negative 9.8 times whatever that t final is. Okay, that's my specific time, the time it took to drop. So the distance that it traveled, or the displacement, I'll just use d here, is going to be the area. It's 1/2 v final times t final. Right, that's just the area of a triangle. And now let's replace the v final. Okay, so we have 1/2, so that we have it just in terms of one variable, minus 9.8 t final times t final. Okay, so when we multiply that, we're going to get half of 9.8 is a negative 4.9, and then we have t final squared, right? But we were given that distance, right? We're given that, it's going to hit the ground after it's traveled 45 meters, because that's how tall the building is, right? So that's the measurement of the building from the ground. So we want to set that equal to 45 or negative 45, right? equal to 45 meters. All right, now we have an equation we can solve. We're just going to divide each side by 4.9. So we get T final squared is equal to 45 over 4.9. Okay, now I canceled the negative, right? Because negative divided by negative is positive. And then I'm just going to take the square root of both sides. Let's take the square root of both sides. Okay, and we get the T final is equal to, what did I get? 3.03 seconds. All right, so that answers one of the questions. How long will it take to hit the ground? That takes about a little over 3 seconds for it to hit the ground. All right, so now the other question is just how fast. How fast is it going when it hits the ground? And we have this equation that up here. The V final is just negative 9.8 meters per second every second, and it does that for 3.03 seconds. Okay, so if I multiply that out, what do I get? I got a negative 29.7 meters per second. So that's the velocity. That's the velocity. Now, how fast was it going? Maybe they're referring to speed, right? It could be referring to speed. So I could say that the speed was 29.7 meters per second. Okay, that's how fast it was going. So if they want speed, then I just take the absolute value of the velocity to get the speed. Okay, but the negative just indicates that it's falling in the downward direction. Okay, so the velocity has direction, speed doesn't. So, all right, so I think we've answered all the questions. It takes a little over 3 seconds for the object to hit the ground, and it'll be going 29.7 meters per second when it hits. All righty. Well, that's all the examples I have for this section. Man, that was a long one. All right. So I will see you in class.